Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 38 of Physics 5054 of GCSE. Today we are going to discuss a very important topic of this chapter which is all about the pressure, and that topic is pressure in liquids. Ladies and gentlemen, pressure is not only associated with the solids and gases, it is found in the liquid as well. The pressure in the liquid depends on its weight. To explain it further, let us consider a tall vessel of water with a side tubes at different heights. The first outlet is at height H1 and the second outlet is H2, and similarly the third outlet is at H3 level. So we can see that the uh, outlet 3 spurts the water further than these two outlets. Similarly, outlet 2 is spurting out water more furthest than the outlet 1. It shows that pressure in the liquids depends on the height. Pressure depends on the height. At height 1, the pressure will be 1. At height 2, the pressure will be another. At depth 3, the pressure will be another. How we will find that what is the pressure at a specific depth? Let us derive a general formula and then we will specialize that formula for a specific depth. For that, let us consider a column of water whose height is h. Let me write h is equal to height of column and A is the base area, and there is another terminology we will use, and that is density of the liquid. Density of liquid. So these are the three terms we will use here. W is the weight of liquid. W, weight of liquid. Weight of liquid. Ladies and gentlemen, first we will explain that this shape is a cuboid, and you have to consider that this cuboid is filled with the water, with the liquid. In this particular case, we are generalizing it, so we will not take the name of a particular liquid. We are saying that it is a liquid. Now, area of cuboid In this case, the column of liquid is base area into height. Remember, this is a formula for finding the area. So in this case, area volume, not this is volume of cuboid. So this will be V, and this is the area, and that will be H, and we are labeling it with equation 1. Now we will find the mass. So for that we know that density is equal to mass per unit volume. This implies that M is equal to rho into V. So mass of the liquid will be equal to rho, which is called density of the liquid, and V is the volume. Because we will need this equation in another equation, so we are labeling it as 2 to refer it at that time. Now, W, weight of liquid column is equal to mg, where m is the mass of the liquid and g is the gravitational field, gravitational force, you can say. Now this is W is equal to mg, and we are labeling it as the third number equation. Now because we are finding the pressure, so pressure is equal to force per unit area, and we know this from the previous lecture. Ladies and gentlemen, instead of F, we can write A as well, because weight is also a force with which the earth attracts a body towards its center. And here also we are having weight at a certain depth. So we can replace meaningfully this F by W. And you know that W is equal to mg. Here it is W is equal to mg, and we are writing this A on its place. Now M is from equation number 2. P is equal to, we can write instead of this M rho V. Rho is the density, and A will be on its place. Further, when we can replace this V by AH. So rho AH G divide by A. So we can cut this A by this, and we will be left only with rho G H, and this is the pressure in the liquids. From this equation we can deduce that pressure in the liquid depends on the height and density of that liquid. G is constant for everyone. We will put everywhere the value of G as a constant, which is 9.8 to be very much correct, but for your convenience we can take it as 10. So densities of different liquids are different. So we will put this value according to that liquid of which pressure we are required to find, and H is also variable. So this H is also. So I can write pressure in a liquid is equal to density of liquid multiplied by height of liquid column multiplied by gravitational force, which is G. So you can define as the multiplication of density, gravitational field, and height of the column is known as pressure of the liquid. One consequence of this equation is that water maintain its level. Water maintain its level. For example, there is a vessel in which there are two of the places which are like this. So, ladies and gentlemen, if water is there inside that and one is this much filled and the second one is this much filled and the third one is this much filled. These are the containers which are filled like this. So, ladies and gentlemen, we have to do what? The pressure of atmosphere will push it down to push this vessel level upward, and it will be in level with this one. Similarly, the pressure of this will be in this. So it means that it is not possible that the level of water in this will be 1 and the level of water will be this and different in the third container when they are connected to each other. For example, this container will be filled this much and this will also be filled with this much. So it means that water maintain its level at certain depths. Let me give you another example. If there is a water tank and if there is, for example, this is a water tank at the top of your building roofs and there is a water tap. So this water will come with the greater pressure here because it is far below. But if this tap is made here, then water will not come out from this tap because it is above this water surface, and I told you that the water level always maintain at its surface. Ladies and gentlemen, if you are making, this is the surface of water here, and you are making the tap here, you will not receive any water because this tap is above the surface of the water. Let me give you another example. If there is, and that is very important example from the civil engineering point of view. So if this is a room and the mason is laying down the floor, so they have to give a slope to it, so the water will go out to certain level. How they will measure this? There is a pipe level available with that, and they are putting hot water inside it, remember, in a plastic small pipe. So they are having to keep this water pipe there and putting a water inside it. So if they are moving it upward, the water level will also go upward. If they are moving it down, so the water level will go down. So on this side, they are marking a place like this, and on this side, which is a bit reduced, first they are saying that this is the flat level, no slope is there. Then they are reducing that 1 inch or half inch of slope should be there. So they are uh, putting the pipe level down and marking it. So from this mark, then they are bringing like this. So water maintain its level, and all the masons and engineers are using very precise measurement by this pipe level. So that was a topic which arose due to this equation, and I wanted that I should explain it to you as well. There is another uh, example, work example on page number 101. We will do that example to learn the practical usage of pressure in liquid. And there is a conclusion for you. So let me erase this portion or this portion somewhere, and I will do that. Wait for a second. Okay, ladies and gentlemen, there is a worked example 7.1, and it is saying find the pressure of find the pressure acting on a diver when he is at the surface. This is 7.2, and we have to find the pressure, but you have to recall that pressure is equal to rho g h in liquid, not in solid. We are perfectly talking about the liquid, not the solid, not the gases. This formula is only applicable when we are finding the pressure on something in the water. Okay, so find the pressure at the surface. There is a diver which is at the surface of the water. So in 1 number part, we will write that at the pressure at the surface of water is equal to 1 atmospheric pressure, which is nearly equal to 1.01 into 10 raised to the power 5 Pascal. Now, in the second part, they are saying that find, and this pressure at the surface of water will be P naught. In the second part, they are saying that find the pressure when the diver is at 10-meter depth. So we will say that H is equal to 10 meter. Here we are saying the density of liquid, which is water in this case, which is given 1000 kilogram per meter cube. This is the data given in that. And then G, we know that this is the 10 meter per second square. Ladies and gentlemen, when the diver at 10-meter depth, pressure at the surface plus pressure at that which is rho g h. Now we found this P naught here 1.01 into 10 raised to the power 5 into 10 into 10. G is also 10 and H is also 10. So we are saying that this is the Pascal. Now we are taking uh, this G is, we put this value for this, but we have to put for this row as well. So that will be 1. Uh, this row will be 10 raised to the power 5. The second value will be 10 raised to the power 5. 1 into 10 raised to the power 5. So we are taking 100 as a common, and when we calculate this, it will be 2.01 into 10 raised to the power 5 Pascal. Yes, it is like this. So we are seeing that at the 10-meter depth, the pressure on the diver is almost twice at the pressure of that at the surface of water. So I am writing, we can see that at 10-meter depth, the pressure on the diver is twice as much as at the surface of water. You have to keep this in mind because at the surface it is 1.01, which is here into 10 raised to the power 5, but at 10 meter it becomes twice 2. This is 2.01, this is 1.01, and this is 2.01. So that was the whole story about the pressure in the liquids. Thank you very much for watching. Allah Hafiz.